Hey everybody, today we're going to look at Module 1, Lesson 9, Scientific Notation. We've been working with numbers times powers of 10 this week, and I really wanted to start off by just giving us an example that resembled the problems that we've been working on. So use your polling tools, and we will go over this question in about 2 minutes while everyone gets settled into class. So at this point, I would leave the timer on for 2 minutes, and then we would go over the question and discuss what the process was for answering the question and how we came to our final answer of D. During my lesson, we would then go over our objectives. Your objective for today is to write, add, and subtract numbers in scientific notation and explain what is meant by the term leading digit. At this point, we can't add or subtract numbers until we actually know what scientific notation is. So this lesson will be spread out over 2 days. The first day today, we're just really going to focus on identifying numbers in scientific notation and writing numbers in scientific notation. Standard that we'll be looking at is also on the board. We're going to perform operations with numbers expressed in scientific notation, including problems where both decimal and scientific notation are used. So what exactly is scientific notation? At this point, I would ask a student to read the board. The first part makes a lot more sense than the second part to the students. When they read a positive finite decimal, S is said to be written in scientific notation if it's expressed as a product D times 10 to the N. I know that that's going to raise a lot of questions. I'll tell the students that don't let the smoke come out of your ears. Let's talk about what that really means in some terms that we can understand. First off, the word finite means that the decimal does not go on and on and on and on. It is a decimal that does stop. And when we're looking at a number equal to 1 and less than 10. So most of the time we can think of that as a number between 1 and 10, but it can also include 1. And then we also have the exponent being an integer. So let's talk about that in terms Mrs. Barrett can understand and hopefully makes it a little easier for you. So we're going to start off with a number that is between 1 and 10. Remember, this can include 1. So that's really important to remember. And then multiplying it by a power of 10. Powers of 10 is something we've been working with this week. And then the exponent has to be an integer, positive or negative number. Okay, so let's start off by just identifying numbers between 1 and 10. I mean, again, they can include 1, but cannot include 10. So I would have the students circle the numbers between 1 and 10 at this point, and we would discuss whether or not a number was actually between 1 and 10 based on how they answered. So they should be able to circle all of the numbers that are between 1 and 10. So if the students would have, again, circled one that wasn't between 1 and 10, we would discuss why it was not. Okay, so we know that scientific notation, we have to start with a number that is between 1 and 10, and we multiply it by a power of 10. So there's 3 things that we're looking for. We're looking for a number between 1 and 10 times and then a power of 10. Can you find one of these that is not written in scientific notation? At this point, I would ask for student volunteers to circle one, and then we would discuss. There are actually 3 here. I always like to have an answer page next so that if it gets a little bit messy with the board writing, that students have a nice clear slide where they can see which answer choices should have been chosen here. So are the following numbers written in scientific notation? We decided that this one was not. Students hopefully were able to explain because there's addition there. This one does not have a lead digit between 1 and 10. And this one not only does not have a lead digit between 1 and 10, it also does not include a power of 10. Next, we would talk about how we take an original number and write it in scientific notation. So we would start with our number and decide where the decimal needs to go. I would ask students to contribute in the chat box here. Between what 2 numbers should I place my decimal? Once we decided that it needs to go between the 1 and the 3, we decided we need to talk about how we got it there. How many times did we have to move that decimal from where it started to where it is now? Students would be able to count that and tell me in the chat box or grab the microphone. And I would tell them and let them know that that's a really important number, because we were talking about multiplying by powers of 10 earlier in the unit. And we talked about how when you multiply by a positive power of 10, our decimal moves to the right. And when you multiply by a negative power of 10, the decimal moves to the left. So we know that multiplying by powers of 10 have our decimal moving one direction or the other. So we would consider that we moved 4 places. So how do we get this number to represent our original? We know that we'd have to move it 4 places back. And that's where that 4 is really important. We move the decimal 4 places to the left. So our exponent is 4, because we're going to need to move it 4 places to right to represent our original number. That's why it's a positive 4. At this point, we would stop and ask students to ask questions, although they're always encouraged to use the question and answer chat to do so. For students that like to take notes, these notes will be provided for them, because I don't like to encourage a lot of writing in class, but I do like to encourage them to write down examples and things like that. But I also provide study guides. So here are the steps for writing a number in scientific notation. And that way the students will have this. They can kind of go through it as a checklist. All right, so at this point, we're going to work as a team, kind of in the we do model, and we're going to look at 5 different examples for writing in scientific notation. The first one we would do together. So we would take a look at where we need to place the decimal. I would have students contribute either on the microphone or the chat, letting us know that we need to place it between the 2 and the 0. So I would be writing this on the board as we were kind of going over it. We know that we need to multiply that by a power of 10. So that part we can fill out. And then we just need to decide how to find that power of 10. Looking back at our original number, we had to move the decimal 3 places to get it between the 2 and the 0. So I know that my exponent is going to be 3. To decide whether it's positive or negative, I'm looking at my original number here I'm looking at my original number and comparing it to the new number. I know that to get from this new number here back to the original, that decimal needs to move back 3 places to the right. And that's why it's positive, because we're actually representing a number 2036. So we want that number to grow. That needs to move to the right. After going over the first one with the students, we would have student volunteers work on the other ones, or at some point, I just would open up the whiteboard and say, okay, let's all do number 5 together, and just type your answer in there. Okay, again, I like to have answer pages so that those that are following along or taking notes or writing down examples can see some nice, neat typing on the board. Sometimes when we're contributing on the board with writing tools, it gets a little bit messy. So on this example, it shows I have highlighted the blue here just to represent the numbers that we moved around when we were moving our decimal. Okay. For the I do of my portion of this, we would just use some polling tools just to kind of get a gauge of where the students are at, how many are understanding the concept. So I would have 2 examples. And I also like to include that I need more time because it is hard to know exactly how much time to give them. Sometimes I give them a minute or 2 minutes. I know some students need more than that. So that's what we look at. And then we would go over, again, each answer. So I have 2 examples here where we're going to try that. Going over each answer. I love color coding. I feel like the visual of that really helps the students. Okay, and then there's another one here in which we're going to identify the number which is not in scientific notation. So again, these students should be looking for a number between 1 and 10 times a power of 10. There's only one of them there that does not start with a lead digit between 1 and 10. So I would ask a student to get on the microphone and describe why that one is not in scientific notation. Okay. Tomorrow, we are going to start changing the magnitude of numbers in scientific notation so that we are able to add and subtract those numbers. So this is a good introduction just to that, just to show that we can write the same number with different magnitudes. So I would have them consider this page and let me know true or false. Oftentimes I use the green check or red X for that. True or false, is that equal to each of the following? And then we would discuss how that was true, and then have the students identify which one of those was written in scientific notation, just to kind of lap back to what we've been doing with scientific notation. We'd go over what we did today in class, just knowing how to write numbers in scientific notation, why it's important that we do that. It allows us to determine the order of magnitude of a finite decimal. And then I would have an exit ticket. So the exit ticket would be how I would assess the students. Most likely would offer a Google form for this. A Google form is something easy that I can look through as well. In addition, there would be a homework in the online school, and that's how I would assess the students. As far as differentiation, that's where my students would have the choice of saying, I don't know. Frequent checks in the chat box throughout the lesson. And then with the exit ticket, if we had students who had reduced choices or reduced questions, I could ask them to choose just one, choose two, choose three, depending on the level of that student and what their SDIs are. Thank you for my mini lesson. I hope it was what you were looking for.